Hi, so this is Mr. Kramer. We're going to go over some ideal gas law practice problems just so that we can see how these are done and how to best use this equation to solve all of these problems. So I've pulled up the quiz here. Again, I encourage you to do these on paper, and so I'm going to model that today. And then also I have an online calculator that you can use right here for when it's time to plug in the numbers. So here it gives me the equation, and it gives me each of the gas law constant, or what R is going to be. So let's go ahead and get started reading the prompt and getting to work. So it says, what pressure will be exerted? So that before I go any further, I know what variable I'm solving for. It's going to be P. So what pressure will be exerted by 5 moles of gas contained in a 2-liter cylinder at 329 K. So those are all the pieces of information that I highlighted. So let's cut over to this and write down some of that information. So we know that P is what we're looking for. That's the big question mark for today. So it told me a few other pieces of information. So it said I had 5 moles of gas. So N is going to be 5 moles. This is the equation here. Okay, 5 moles. Then it also told me that I had a 2-liter cylinder. So 2 liters is a way of measuring volume. So volume is going to equal 2 liters. And then the last piece of information, it told me that it was at 329 Kelvin. Well, that's a temperature measurement. So here we have the moles, we have the volume, we have the temperature, and we're looking for the pressure. Here's my equation. So I just got to start plugging in the variables, just substituting in what I know in order to get the right answer. So how am I going to find R? Well, R is given to me in the problem statement. So if I go back to the problem, we see that R is given as 0.0821. So I'm going to put that down into my onto my piece of paper. Like so. So R is 0.0821, and then the temperature is given 329. So to solve for P, I need to get P by itself. So always, whenever you're doing algebra, the goal is to get your variable by itself. That's always the goal. So all of these are just numbers. These can be multiplied together. So 5 times 0.0821 times 329. So I'm going to use my online calculator to do that. So switch over here. So I have 5 times 0.0821 times 329. And that gives me 135.05. So I'm going to put that on my piece of paper down here, which I'll cut to in a second. 135.05. So if I go back to my paper, that's what I found here. And then on this side, I just have the number 2. So 2L still times P. So I'm going to divide both sides by 2L to get that way when I'm all said and done, the P will be by itself, and divide both sides by 2L. So there we go. So then I have 135.05 divided by 2 liters. So I'm going to go back to my calculator. So I have the same number I just had. I'm going to plop a division sign in front of it. Oops, no, that didn't work. Here, plop a division sign in front of it and put a 2 there. And then I get 67.5. So 67.5. Cut back here, so P equals 67.5 ATMs. So that's quite a bit of pressure. And then when I go back to my quiz, it says to round to 2 decimal points. So I should go get 1 more decimal point for my answer. So 67.53. So that's what it means by 2 decimal points. 67.53. We'll put that in here. 67.53. And then I would move on to the next problem. So here's another problem solving for volume. I'm going to skip over this one for a second and do this one. This says, at what temperature would 2.1 moles of gas have a pressure of 1.25 ATMs in a 25-liter tank. Okay, so I'm going to go back to my paper and start writing down my equation and the things that I know. So next problem. So I'm still going to use the same equation, PV equals nRT, but this time I have different things that I know. So I have the moles of gas again, that's 2.10 moles. It tells me the pressure this time. The pressure is 1.25 ATMs. And then it also tells me the volume again. So volume equals 25 liters. So these are all the things that I know. Plus, I always know that R equals 0.0821. So that's just a constant. Okay, so now we have this equation. Which variable are we solving for again? It said that I wanted to find the temperature. So I'm going to be solving for the temperature by itself. All right, on this side, I know both P and V. So I have pressure. I'm going to substitute as 1.25 ATM. And then for volume, I'm just going to substitute this right over here. It's 25 liters. Okay. And then on this side, I need N, R, and T. So N is right here, is 2.10. 2.10. R is 0.0821. 0.0821. And then T is, oh, I don't have it. So that's a variable. So this is the one thing I'm solving for. So what I need to do is get this T all by itself. So I'm going to do that first by simplifying each side and then dividing, just like we did last problem. So I'm going to do 1.25 times 25. So let me go to my calculator. So clear all. So 1.25 times 25. And that gives me 31.25. And then on the other side, I had, clear all, I had 2.1 times 0.0821. And that should give me 0.17241. 0.17241 times T. Okay, so I'm going to pop back to my paper and see what I've got. So I have 31.25 equals 0.17241 times T. So in order to get T by itself, again, I have to divide both sides by this number here. That'll cancel that out. I'll be left with just T on this side. And then over on this side, when I divide 0.17241, I need to use my calculator to find out what this fraction is. So I go back to my calculator. So clear everything. I'll just do 31.25 divided by 0.17241 and put it in my calculator, and it gives me 181.25. So if I pop back over to my paper, I just took this number divided by this number. That's this. On this side, everything else canceled, so I was just left with just T. So that's the general strategy. This will obviously be in Kelvin. And so when I go back to my quiz to punch in my answer, it says round your answer to the nearest whole number. So I just need to put 181. So that's the nearest whole number. That means no decimal points. So that would be my answer for that one. So I only answered 2 questions, but if I submit my quiz, we'll see if I got them right. So this one I got right, and then this one I also got right. So great, didn't make any mistakes, and then I'm well on my way to completing the rest of this quiz. So best of luck with this. If you have questions, send me an email, and I'll talk to you later.